Hi, in this video we'll talk about the BIMWERX suite of analysis and design software tools. On the left we've got GenFEA X, our multiphysics analysis engine, and GenMesh X, our surface and structured volumetric meshing engine. Those two engines feed into both the GenFEA desktop and GenFEA web structural analysis and design software. It also supports ConnectFEA with parametric structural connection analysis and design tools, and our computational fluid dynamics tool WinCFD. We'll also talk a little bit about TrafficSIM for vehicular traffic management planning and analysis. So GenFEA X is a multi-physics analysis engine with advanced capabilities. It can be used with GenFEA Desktop and GenFEA Web as a general structural analysis engine. We support a standalone and integrated or API version of GenFEA X, meaning that we can plug it into the existing suite of software within the BIMWorks software suite or your own custom tools. In the example on the screen, you can see GenFEA X results produced using the GenFEA Web interface. We also support solid models with contact elements for multi-physics simulations, such as the one that you see on the screen from ConnectFEA. We utilize the Paradiso MKL backend solver, meaning we can achieve reliable and fast results for complex models. GenFEA X also features computational fluid dynamics capabilities with smart element classifications optimized for structural design solutions. GenFEA X uses a meshless CFD solver, meaning that we can solve complex and large domains much faster while maintaining a high level of accuracy. The graphical outputs and summaries provide insights for structural engineers. So GenFEA X also comes with a full API that is really well documented and easy to use. But on top of that, we've also trained a custom GPT on the API capabilities and methods so that engineers can easily use AI to help generate scripts in order to create your own efficiency tools, structural utilities, and scripts using this powerful solver API. In finite element analysis, meshing can often lead to complications within the solving of problems. So what we have done is we've created a really powerful meshing library and engine to deal with triangular and quad meshes where it is applied to planar shell elements, and then the structured volumetric mesher that is built into tools such as ConnectFEA. This allows us to have greater control over the mesh elements and assignments when it comes to downstream contact and time mechanics solving. So GenFEA is our structural analysis and design software designed for desktop. It uses a smart system of intelligent objects to create advanced 3D modeling features, whether that is by manually adding to a model using the spreadsheet style input workbook on the left-hand side, or importing models from external sources. It has parametric behavior, meaning that the objects are intelligent and connected in a smart way. GenFEA also features a custom section properties calculator that allows you to generate any new parametric section types or arbitrary sections directly within the tool to calculate cross-section properties and add to the GenFEA library. So thanks to the powerful GenFEA X analysis engine that runs in the back end of GenFEA, it means that we can support a wide range of analysis types within the software. And those include linear static analysis, linear dynamic analysis, response spectrum analysis, buckling analysis, nonlinear static, p-delta analysis, second order analysis, and also nonlinear dynamic analysis types. When it comes to the design functions within the workflow, we've taken a different approach. We've built in a scriptable design calc sheet system called DesignPad. And what this allows users to do is to either use existing library templates for component design or create their own design scripts. And of course, that plugs into exports such as those from Microsoft Word. And we use this tool to generate detailed reports for visual outputs. The built-in AI assistant named DesignMate allows for custom AI design scripts, meaning engineers can design any element to any standard. This also supports multiple LLM providers, including those of local LLMs. GenFEA Web is the next step in evolution for the GenFEA software. It is 100% browser-based, meaning that no installation is required. The interface is intuitive and easy to use. It already supports multinational libraries of sections, but you can also use the custom section property calculator to define arbitrary shaped custom sections and calculate their properties, or select from existing parametric section shapes and do the same. We're continuously building in new model generators in the form of wizards. The example on the screen shows the dynamic and interactive portal frame generator. The back end still supports the GenFEA desktop spreadsheet style interface, and lots of tools exist to optimize and discretize models and linking that information between the input workbook and the modeling environment. Defining non-graphical analysis setups such as load cases, load combinations, and assigning those to the model is easy to do, and we can then link that analysis definition through to the desktop run GenFEA X engine. Again, this requires no installation. It is a standalone application, and it connects directly to the GenFEA web model, sending information to and from the engine to the web interface where we can visualize results and outputs. Model data is cached, so if there was a browser interruption, it means that those points can be restored and work is never lost. We've also redesigned our design pad or calculation engine that plugs into GenFEA Web, and this allows for even greater visual outputs and calculation math rendering in reports and design sheets. And of course, we can export this again to Word, and we maintain elements such as equations and graphical outputs for detailed report writing. You can choose from the existing library of design sheets or create your own on the fly. Then probably one of the most exciting and most advanced features of GenFEA Web is its capability to connect directly to AI agents such as those from Codex, Claude Code, or OpenClaw. And what that means is that we've gone above and beyond the general use of an AI chatbot within the software to connecting these agents directly to the back end of GenFEA Web to drive the software, take visual screenshots, and use computer vision and the backend data to validate what's being generated. In the example test here in the screen, we've pointed Codex with its latest model to a project folder with some existing information, PDF drawings and model files. We've provided a desired objective and outcome, and we had it automate the process of generating our structural model, assigning load cases, load combinations, and loads to the model. This is the next step in AI automation. It also doesn't require any custom developed MCP servers. It connects to GenFEA Web directly. So ConnectFEA is our parametric structural connection analysis and design software. It probably sits in the same family as that of the Idea Statica software. It uses the same XLSX or spreadsheet input logic that GenFEA utilizes, and that just means that we can create any parametric and formulated configurations for structural steel to steel or steel to concrete connections. Having that parametric capability is really essential, as that allows us to create formulas and connect element values together in order to maintain a dynamic and parametric structural connection environment. Structural steel connector tools also exist within the modeling environment, meaning that we can easily connect elements together using bolt groups with predefined properties and parameters, as well as weld groups in the system. Smart subsurface splitting within the software is run in the back end, and this just means that when we get to the downstream processes of automatically assigning tie and contact mechanics, that the software can deal with it in a smart and efficient way. The solver processes the information in a parallel computing environment, and this just means that we get results faster, great visual outputs, and we plug it into the design pad for ConnectFEA for great calculation outputs and exports to Word. So WinCFD is our computational fluid dynamics for structural wind loading solution. It allows for importing from various formats, including IFC, and it supports model scales from small to large scale models. It uses a meshless model system as well as parallel computing, which means that we can efficiently solve large scale models in a record amount of time. The outputs are visual as well as tabulated and allows for greater insights into wind loading on complex structures. Detailed results can be visualized through CFD slices in various planes along the model. This is a really great tool for engineers to understand complex wind loading on structures from small to large scales. One of our more recent developments, TrafficSIM, is a vehicular traffic management and planning and analysis tool, 100% browser-based once again. It allows us to generate contextual models in a federated model environment with some OpenStreetMaps overlays to start defining traffic network systems. The tool is interactive and it uses smart controls so that we can model junctions, lanes, arterial roads and motorways in order to simulate traffic flow. The purpose of the tool is to understand the impacts of temporary works and permanent works and adjustments in the network and to see how that affects the wider network. The tool runs interactive and is dynamic, meaning that we can see real-time results and impacts on traffic based on a color code scheme. So green cars meaning cars are moving at the desired speed of the speed limit, and then orange meaning that there is some traffic block, and red meaning that we've got a larger block in the network system. Making changes to the model in real time has a direct effect on the traffic flow and is immediately simulated and resulted. It is a great tool for traffic management planning. If you found this useful, head over to our website for more information and make contact with us. Thanks, bye.